So let me start 3D, three-dimensional geometry. How to find the equation of a line passing through a point which is x1, y1, z1. Let's name it as A vector. Parallel to another vector B vector which is got the vector form direction ratios as AI plus BJ plus CK. Consider an arbitrary point x, y, z. You know this and this vector are parallel to each other. So let's write what is this vector. At the base is x minus x1, y minus y1 and z minus z1 is this vector here. And that and the above vector are parallel to each other. So x minus x1 by A is equal to y minus y1 by B is equal to z minus z1 by C is equal to lambda. It's like two parallel vectors. The direction ratios are proportional. So I'm using the same thing. So equation of a line passing through the point x1, y1, z1 which is called an A vector parallel to another vector B vector whose direction ratios are AI plus BJ plus CK. Then you can imagine an arbitrary point R vector which is x, y, z, and this vector is parallel to this vector. So x minus x1 by A is equal to y minus y1 by B is equal to z minus z1 by C is equal to lambda is the equation of this line. So supposing this is the way in which you write a Cartesian format. Supposing you want to write a vector format, you know this x stands for R vector because x belongs to an R vector. The x1 here belongs to A vector. So R minus A is equal to lambda times these denominators have come from the parallel vector which is above. So that's nothing but B vector. So R vector is equal to the A vector which is the point plus lambda times the B vector which is the parallel vector, the direction. Okay, so that you must be clear with this. Then the vector form and the Cartesian form. The Cartesian format is this. The vector form is R vector is equal to A vector plus lambda times B vector. A vector means the point which is this point and the B vector is the parallel vector. So now equation of a line passing through 2 points. Supposing you have an x1, y1, z1 which is A vector, another x2, y2, z2 which is another point which is B vector. Now consider an arbitrary point R vector which is x, y, z. Can you see that this vector is parallel to this vector? So then the ratios will be proportional. So x minus x1, this is x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1 is equal to lambda is the Cartesian format of this equation. And again you have an R vector which is x minus x1 which belongs to A vector by B minus A, and x2 minus x1 is B vector minus A to the lambda. So R vector is equal to A vector plus lambda times B vector minus A vector which is a subtraction of the two direction cosines, direction ratios. So this is the format. So these are the two formulas you must be really clear with to start doing 3D. So then equation of a line joining one point, passing through one point parallel to B vector which is x minus x1 by A is equal to y minus y1 by B is equal to z minus z1 by C, where A, B, C is the parallel vectors. Okay, the direction vectors. And x1, y1, z1 is nothing but a point. So then let's do some sums. If you're clear with that, let's take page number 477. Sum number 1. Show that three lines with DCs are mutually perpendicular to each other. They've given the 12 by 13 into I minus 3 by 13 into J minus 4 by 13 into K, right? Like that as in vector form. Next is 4 by 13 into I plus 12 by 13 into J plus 3 by 13 into K, again in vector form. Next 3 by 13 into I minus 4 by 13 into J plus 12 by 13 into K. To show that they are mutually perpendicular, you know, this and this has to be dotted. If it becomes equal, is equal to 0. The dot product is equal to 0 means it's perpendicular. Dot this and this, the dot product is equal to 0, it's perpendicular. Dot this and this. You know you can only dot on i's and i's and j's and j's and k's and k's. So let's do this. 12 fours are 48 by 169. Minus 12 threes are 36 by 169. Minus 4 threes are 12 by 169. Okay, if this is nothing but 48 minus 48, it will become 0 and therefore they are perpendicular. Let's compare this and this then. 4 threes are 12 by 169. Minus 12 fours are 48 by 169. 12 plus 12 3s are 36 by 169. This is also 0. Thus you can conclude that they are mutually perpendicular to each other even by dotting this and this. So then dot those 12 3s are 36 by 169 plus 12 by 169 minus 12 4s are 48 by 169. The answer is 0. Thus all the three vectors when dotted are 0, and therefore when the dot product is equal to 0, they are perpendicular to each other. So let's go to the next question, which is the second question. Show that the line through the point 1 comma minus 1 comma 2 and 3 comma 4 comma 2 comma 3 comma 3 comma 4 comma minus 2 is perpendicular to another line which is passing through the point 0 comma 3 comma 2 and a 3 comma 5 comma 6. To prove that they are perpendicular, you just need the direction of this and the direction of this. And if the dot product is equal to 0, then they are perpendicular, correct? So you just need the direction of this vector, which is 3 minus 1, x2 minus x1 into I, plus y2 minus y1 into j, plus z2 minus z1 into k, minus 4k. You got this vector? Do the same thing here, x2 minus x1 into I, plus y2 minus y1 into j, 5 minus 3, and a 6 minus 4. You dot product these two vectors, and if it's equal to 0, then they are perpendicular to each other. 3 2s are 6, plus 5 2s are 10, minus 4 4s are 16 is equal to 0. The i's and i's and j's and j's and k's can be dotted. So therefore they are perpendicular. Let's go to third question. Show that the line through the point 4 comma 7 comma 8 and 2 comma 3 comma 4 and another line minus 1 comma minus 2 comma 1 and 1 comma 2 comma 5 are parallel. To prove, you just need the this vector and this vector. One vector is lambda times another vector, or in other words, a1 by a2 is equal to b1 by b2 is equal to c1 by c2 is equal to lambda, or one vector itself is lambda times another vector. So both these conditions are applicable for parallel. So let's find the directions of this. x2 minus x1, 2 minus 4 minus 2i, minus 4j, minus 4k. I got this vector. Let's get this vector. It's 1 minus of minus 1 is 2i plus 4j plus 4k. I got this. Can you see this is just minus 1 times other? One vector is minus 1 times other, which shows that it's lambda times other. So you can say that 1 is lambda times other when lambda itself is minus 1. So this is parallel. Or in other words, you can say a1 by a2 is equal to b1 by b2 is equal to c1 by c2 is equal to lambda, where minus 2 by 2 is equal to minus 4 by 4 is equal to minus 4 by 4. The direction ratios are all proportional and is equal to minus 1, and hence they are parallel to each other. So that's one way of doing it. So let's go to fourth question. Find the equation of a line which passes through the point 1 comma 2 comma 3 and which is parallel to vector plus 3i plus 2j minus 2k. I told you this is like take an arbitrary point x, y, z. This vector and this vector are parallel to each other. So let's find x minus x1. This is, call it as x1, y1, z1, which is also your a vector. This is your b vector, which is ai plus bj plus ck. So you understood that which is an a vector, which is a b vector. What do you call it? So the formula is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c is equal to lambda. So x minus 1 by 3, which is the direction vector here, is equal to y minus the point 2 by the parallel vector is equal to z minus z1, which is 3 by the parallel vector is equal to lambda. So this is the Cartesian format, and if you want it in vector format, r vector is equal to a vector plus lambda times b vector. A is the point vector, which is x1 y1 z1 1i plus 2j plus 3k plus lambda times a 3i plus 2j minus 2k will give me the vector format of this line. So let's go to next question. The fifth question. Find the equation of the line in vector in the Cartesian form. The line is passing through the point 2i minus j plus 4k, which is your a vector, and the direction vector b vector is 1i plus 2j minus 1k. So let's consider arbitrary point x, y, z. It's x minus x1 by a. This is your ai plus bj plus ck. So you understood. So x minus x1 by a is 1, is y minus y1 by b is equal to z minus z1 by c is equal to lambda. It's x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c is equal to lambda. So thus you got the Cartesian format, and if r vector is equal to a vector, which is the point vector, plus lambda times the b vector, which is 1i plus 2j minus 1k. So this is how we write the vector equation of the line and Cartesian equation of the line. Let's go to 6th question. Find the Cartesian equation of the line which passes through the point minus 2, 4, minus 5, which has got a line parallel to it. And I don't need the parallel line, I only need the direction. And what is that? Is 3i plus 5j plus 6k, which is below the line, is what is giving you the direction ai plus bj plus ck. You only need the direction because you consider it as x, y, z. It's x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c is equal to lambda. Thus you get the Cartesian format, and the vector format is r vector is equal to a vector, because this is your a vector and this is your b vector. Okay, a vector plus lambda times b vector. So you write the Cartesian and the vector format of this equation. Okay, let's go to the 7th question. Find the Cartesian equation of the line. Oh, they've given the Cartesian equation of the line already. They're asking you to write the vector form. Write it is equal to lambda and write r vector is equal to, this is your x1, y1 and z1, x minus x1 by a. So what is your x1 is 5, what is your y1 is minus 4, what is your z1 is 6, because with the plus 4 it has to be minus 4, y minus y1, right? So you got your a vector, which is 5i minus 4j plus 6k. And what is your parallel vector? The one that is in the denominator is the parallel vector b vector, 3i plus 7j plus 2k. So then the vector format is r vector is equal to 5i minus 4j plus 6k plus lambda times 3i plus 7j plus 2k. And that is how you write the vector form, how to convert this into vector form. Let's go to 8th question. Find the vector in the Cartesian equation of the line which passes through the origin and 5, minus 2, 3. Write an arbitrary point x, y, z. So x minus 0 by 5 minus 0, x minus x1 by x2 minus x1. Okay, is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. So x minus 0 by 5 minus 0 is equal to y minus 0 by minus 2 minus 0 is equal to z minus 0 by 3 minus 0. So x by 5 is equal to y by minus 2 is equal to z by 3 is equal to lambda is the equation of the line. And supposing they ask me in vector form, r vector is equal to one of the point vector, which can be 0i plus 0j plus 0k, plus lambda times the direction, which is nothing but this in the denominator is the direction, 5i minus 2j plus 3k. So this is how we write the vector form of this equation. So the first 8 sums, I hope you're clear. Okay, just become clear with that, and I'll teach you the rest tomorrow. Okay.